So let's start by introducing what voice conversion is. Given a speech utterance from source speakers, this task aims to convert it to the timbre of the target speaker while preserving the speech content. So the content will be preserved, and stuff like timbre will be changed. But what is non-parallel voice conversion? That is, the training utterances of source speaker and target speaker could be different in content apart from timbre. Actually, the CycleGAN-based methods offer a general paradigm for this, which does not require any parallel data. However, it introduces a strict time-frequency bin level constraint that forces a model to be a bijective mapping, making it hard to ignore irrelevant features from the target speaker, such as stress and pause. For example, given an input utterance with "please call Stella," the output utterance will be strictly the same, like "please call Stella." However, the ground truth of the target speaker would be "please call Stella." Besides, the GAN-based model is notoriously difficult to train, but CycleGAN has 2 GANs, which makes the situation even worse. In our method set contrastive voice conversion, CVC, only 1 GAN is needed thanks to the contrastive-based method. Specifically, given an input utterance with "Hello World," we first input the MEL spectrogram of it to the generator of a GAN, and the generated MEL spectrogram will be obtained. Then we input the generated MEL spectrogram to the encoder of the generator. Notably, this encoder shares the weights of the generator just mentioned. After that, 2 MLP layers are employed and compute a multi-scale patchwise contrastive loss. Concretely, we sample some patches of the whole latent space, and some patches from the input and generated latent space would be positive matching. The others would be negative matching. Finally, the positive samples would be pushed together, and the negative samples would be pushed apart. In our example, a generated spectral patch representing double H should match its corresponding input patch double H, in comparison to other random patches AH, W, or D. We also provide some quality results here. For many to 1 VC, our CVC method can generalize well to real-life scenarios. This is an example that we transferred Joe Biden's voice to Barack Obama.
Good morning together. But I want to say hello to everyone and thanks you at the Munich conference for hosting this special session.
Good morning together. But I want to say hello to everyone and thanks you at the Munich conference for hosting this special session.
Here is another example where we transfer Mark Zuckerberg's voice to Barack Obama.
After one particularly tense argument, one of my close advisors told me if I didn't agree to sell the company right now, I would regret that decision for the rest of my life.
After one particularly tense argument, one of my close advisors told me if I didn't agree to sell the company right now, I would regret that decision for the rest of my life.
And that's our presentation. Thanks for attention.